Today we have to discuss the laws of refraction using Huygens principle. Before that, you must have studied about the Huygens principle. I am just repeating it, that it shows that if there is a wavefront, or suppose I am taking a plane wavefront, if there is a plane wavefront, every point on this wavefront act as a source of secondary wavelet, and these wavelets can be shown in the form of spheres. Taking these points as center A, B, C, we can draw spheres and that will behave as wavelets, and tangent to these wavelets gives you the secondary wavefront. This was the Huygens principle which we will use to prove this laws of refraction. Now to prove the laws of refraction, what I have to take and what I have to prove, you must have studied in the ray optics in class 10th also. What are the laws of refraction? First is the Snell's law, and Snell's law is that sin I by sin r is equal to the speed of light in vacuum to the speed of light in medium, which is equal to constant. This is sin I by sin r is giving you the refractive index. This is the Snell's law, and second law is saying that incident ray, refracted ray and normal lies in the same plane, and this we have proved in the ray optics. Now we will prove it in the form of wave optics, which was given by Huygens. So for this purpose I am taking here a refracting surface. The refracting surface, let it be xy. Now refracting surface means that the refractive index of this medium and this medium, say one is rarer, another is denser, and I can take the refractive index of these two mediums as mu1 and mu2. Now in the air, if rarer medium is air, the speed of light can be taken as c, and in the denser medium, the speed of light I can take it as v, as the speed of light is less in the denser medium as compared to the rarer medium, that is air. Now consider a plane wavefront is incident on it. Let AB is the plane wavefront which is incident on the refracting surface xy at A. And we have studied that if there is a wavefront, the perpendicular lines to this wavefront gives you rays, and so I can make perpendicular lines on this wavefront as 1 and 2. You can make any number of lines on this wavefront, 1, 2, 3, 4, etc. I have taken two lines, 1 and 2, on the wavefront. Now as one is a ray and this angle is 90 degree, this ray will move straight and will fall on refracting surface, say at B dash, and it will cover a distance of velocity into time up to this. If I say that t is the time taken in moving the ray from B to B dash, then it will move, or it will take c into delta t time. Delta t is the time in moving from B to B dash. Delta t is clear because the speed of light is very large. So I have taken the small time. So c delta t is the time which this ray from B takes to reach at B dash. Now another ray from A, when in the time delta t, when it reaches B to B dash, in the same time the denser medium from the reflecting surface. But in the denser medium, what is happening, that the speed of light is now v. So the distance covered by this ray will be v into delta t, and v into delta t, taking v into delta t as radius and a as the center, I can draw a arc. Now A is the center and I have drawn this arc. This arc is the secondary wavelet, and tangent from B to this arc gives you the secondary wavefront. This is Huygens principle, that every point on the primary wavefront acts as the source of secondary wavelet. तो यहाँ से there is a source of secondary wavelet, and the tangent to this wavelet gives you the secondary wavefront. So if I say that it is meeting at A dash, then B dash A dash is the secondary wavefront. Now A dash and meeting A dash. Now this was the primary wavefront, and if I draw a normal at A, this was the angle of incidence, and primary wavefront which makes an angle of incidence with the reflecting surface also. Similarly, this is the refracted wavefront, and the refracted wavefront is making an angle of R, that is the angle of refraction, with this reflecting surface. Now B dash A dash is the secondary wavefront, AB is the primary wavefront. Now we have to prove the Snell's law. Now I am taking this triangle. Now in triangle AB B dash, I have to take sin I, because I am proving the Snell's law, and Snell's law is sin I by sin R is equal to the refractive index, so I have to take sin I, and sin I, this is the angle of incidence, so क्या हो जाएगा, BB dash upon AB dash, so sin I is equal to BB dash upon AB dash, as this is 90 degree. Similarly, in triangle AB dash A dash, I have to find sin R. This is angle of refraction, so सामने वाली क्या हो जाएगी, perpendicular and upon hypotenuse, so sin R will be equal to AA dash upon AB dash. So dividing 1 and 2, we will have sin I by sin R as equal to BB dash upon AB dash upon AA dash upon AB dash. So AB dash will cancel out. We will have BB dash upon AA dash. Now what is BB dash? BB dash is C delta T. So it will be C delta T. And what is AA dash? ये जो हमने R बनाई थी, ये कितना लिया था हमने, V into delta T. So it is V into delta T. Delta T will cancel with delta T. So I will have sin I by sin R as C upon V, which is equal to the refractive index of second medium with respect to the first. And from the figure, it is also clear that the incident ray, normal and refracted ray lies in the same plane. So this is all about the laws of refraction using Huygens principle.